Welcome. In this video I'm going to show you how you can perform a maximum and a chance corrected effect size for a Cochran Q test. I'm using Python 3 and I'm using it in Jupyter Lab. So for the Cochran Q test there are two effect size measures that are sometimes used. The first is a so-called maximum corrected version of eta-squared, and the other one is a chance corrected version which has a weird looking R as a symbol. Now, it appears that the chance-corrected version seems to be the one that is preferred, but it's also more difficult to calculate, but I'll show you how to determine each of them. So, as an example, I'll use some film preferences. It's fake data, but it serves well. I'll read that as a pandas data frame, so I need to import pandas, and I'm importing it with an abbreviation as PD. That does mean that I've already installed it, and that goes for any of the packages I might be using. You first will have to install the package itself. You can often do that by using an exclamation sign pip install and then the name of the package. Once I've loaded the package, I can use its functions. In this case, the read CSV is the first one I need, and that's going to read the CSV file, and head will show me the first 5 records. Now I've been using as an example the last 4 columns here, which are names of cinemas in Amsterdam. A 1 would have indicated that that person would have visited the cinema, and a 0 that that person didn't. This is fake data, so it doesn't really mean anything, but it's just to show you as an example. Those are the only fields I need, so let's keep those as a separate data frame. And a few basic things that are useful here are the number of variables, the number of cases, the value assigned to a success, and let's also store the names of our variables. So that's actually the first line here. The number of cases, the number of variables, if you like, is then the length of that, so len, and then I can use the shape of this one to actually also get the number, so the number of cases, and a success in my case was a 1. Then the maximum corrected eta-squared. I need a package for that, the stats models contingency table, to get the Cochran Q results. So I run the test. I have a separate video on performing a Cochran Q test. I'm not going to go into the details here, but what I need from this result is now the statistic. So I'm going to actually obtain that separately. Then I can simply fill out this formula. I have all the information I need, and I have my eta-squared as 0.04. The other one will actually require some more work, so in that case, as you can see, we already have here a huge formula looking. For each variable we will need again the number of successes, the number of fails, which is the total number minus the number of successes, and the product of those two. That will actually give us the same as this whole formula. So this is the formula, but this is actually easier in calculation. So this would suggest to take any 2 cases, calculate the absolute difference between them, and then sum all of those. After doing then those sums for all possible combinations, then you actually will end up with the same result as if you would do this, which is slightly easier because if I have the number of successes, which is simply to sum given a condition, and here's that S useful, so that was my number of success. But if you had used 1 and 2, for example, and 2 was a yes, then that's fine as well. Then just all the way where we went earlier, where we defined our success, you can just change that to a 2. Then the number of fails is the number I have minus the number of successes. And then I can actually do the number of successes times the number of fails. So then we have our so-called D. The next thing that we need is for the next calculation is we need the possible number of combinations of 2 multiply times k and then times that capital D. So I can do that like I need a combination function for this part, and then I can simply use this to calculate that delta. Then we focus on the rows. So for each row, we calculate for that person how many successes he had as a percentage of the number of cases. We multiply this with the chance of a failure for that case. So for failure, we can do 1 minus the chance of success. And then eventually we need the sum of each of these. So we sum them all up. And also for the failure. So I can do that with this bit of code here. And almost there. Bear with me. Then we still have this mean. This means mean looking formula. But actually we have everything in there. So I can simply fill out the formula. And then finally I can calculate that chance corrected R, and that's going to be 1 minus that delta minus that mu. So that's going to be in this one. A bit of credit to Stack Exchange, where the formula I used can be found, including some corrections to even the original paper. I don't like to go over all these calculations every time, so I made this small little function myself. And then I can simply just fill it out some information, and it will return to me the result immediately. I'll leave a link to my website where you can find this Jupyter note, or where you can find a link to this Jupyter notebook as well. I hope this video was helpful, and thank you for watching.